Hi everyone. Sorry I'm not there with you today. As you can hear from my voice, I'm still a little sick. But I will be there on Thursday. Hopefully this video will clear up any confusion on the reading yesterday so that you can finish that assignment from yesterday. So this is going to be a really quick lesson on complex numbers and operations on complex numbers. So we've encountered an issue where we've seen the square root of negative numbers before. We see that when we're trying to evaluate the quadratic formula and our discriminant is negative. And the question is, what do we do with this? Well, mathematicians decided to give the square root of -1 a name because it popped up enough in mathematics that we really needed to do something with it. And so we called numbers that are related to the square root of -1 imaginary numbers, and we represent the square root of -1 with the letter I. So for any square root, like the square root of -9, that has a negative number in the radicand, we can separate that into two chunks. I know that -9 is 9 times -1. I know that the square root of 9 is plus or minus 3, and now we know that the square root of -1 is I. Effectively, anytime you have a negative under your square root, you're going to pick up an I in your answer. So for another example, if I had -25 and I took the square root of -25, I know my answer is going to be plus or minus 5I. The 5 is coming from the square root of 25. The I is coming from the square root of the negative. Because I is the square root of -1, if I take I and I square it, I get the square root of -1 squared. And we know that squares and square roots undo each other. So I squared is actually equal to -1. If we look at I and its exponents, we actually get a pretty cool cycle. So let's do that off to the side here. So I'm just going to write a whole bunch of i's. Be patient with me. So we'll start with an exponent of 0. And we know that anything to the 0th power is 1. And that can actually be proved with this mathematical definition of the imaginary number, or the imaginary unit. But we're not going to do that. We're just going to use what we know about exponents. Anything to the 0th power is 1. Anything to the first power is itself. So this should be I. We just discovered I squared is -1. And I to the third is I squared I squared times I, which is -1 times I, or negative I. So each time we're going down this chain, we're multiplying by I. And again, we start to see kind of a cool pattern here. So let me do the next couple. So the next one, we're going to multiply again by I. And I've got a -I times an I. And I know I times I is I squared, which is -1. But I've got that negative in front, and a -1 is going to be +1. And we've repeated our cycle. If I multiply again by I, I'm just going to get I. I multiply again by I, I'm going to end up with -1. And this cycle repeats. 1, I, -1, I. 1, I, -1, I. So we can tell what our answer is going to look like by looking at exponents on I. It's not super important that you remember that, but you are going to see these first few in the assignment that you're working on, because the assignment that you're working on is asking you to do operations on complex numbers. So let's go ahead and talk about those operations really quick. So on your assignment, you learned that complex numbers have a real part plus an imaginary part. That is not how you spell imaginary, Mr. Jolliffe. Try that again. Imaginary. So for example, 2 plus 3i, or 5 minus 4i. So complex numbers are a combination. Complex numbers can have a real part that's 0. It's just imaginary. If the imaginary part is 0, then we're just looking at real numbers on the number line. And you were asked to do math with things that look like this. And it turns out we can treat these just like we treat other binomials. So we can add these. So if I want to do 2 plus 3i plus 5 minus 4i, I'm going to add our like terms. And in this case, like terms mean real with real and imaginary with imaginary. So 2 plus 5 is 7, and 3 plus a negative 4 is a negative 1. And anytime we've got a 1, we just write the variable, or in this case, I. Not so bad, right? We can do a similar thing. We can subtract. So 2 plus 3i minus 5 minus 4i. And remember, when you subtract, that subtraction distributes through the entire second set of parentheses. So we're subtracting real from real and imaginary from imaginary. So 2 minus 5 is minus 3. And then we get 3 minus a minus 4 is going to be plus 7. We can also multiply. So 2 plus 3i times 5 minus 4i. And we multiply complex numbers just like we multiply binomials. We're going to FOIL this out. So we're going to do first, outer, inner, and last. So first is 2 times 5, which is 10. Outer is 2 times negative 4i, which is going to be minus 8i. Inner is 3i times 5, so plus 15i. And then the last one is 3i times negative 4i, which is going to be minus 12i squared. And now we're going to simplify. So we know that we've got 10 minus 8 plus 15, I'm pretty sure is plus 7i. And then we've got minus 12, and we know that I squared is negative 1. So this is actually going to be 10 plus 7i, and then negative 12 times negative 1 is positive 12. And now we can combine those real parts, the 10 and the 12, and we get 22 plus 7i. So add, subtract, multiply. It's possible to divide. We're not going to do that here. That's a little bit more difficult than we need to get into for Math 2+. But it is possible to do that using something called a complex conjugate, which you may have heard about in the reading yesterday. So complex conjugates have the same real and imaginary piece, but the sign in between them differs. So 2 plus 3i and 2 minus 3i are complex conjugates. 5 minus 4i and 5 plus 4i are complex conjugates. The reason these are nice is that when you multiply something by its complex conjugate, those two middle terms, the outer and inner, will cancel. The outer is going to be a 5 times a plus 4. The inner is going to be a 5 times a minus 4. So those middle I terms disappear, and the last term, I times I, we know becomes -1. So when you multiply a complex number by its complex conjugate, you end up with a real answer, which is kind of cool. Okay, ideally, you have enough to make an attempt at the assignment from yesterday. I'm not expecting perfection, but I am expecting you to give it a go because it follows something similar to what we've done before, which is multiplying binomials. And I know that you guys know how to do that. You did really well on that. If you finish early, if you feel really confident with what we're doing, there is an extra credit assignment in Google Classroom, so feel free to do that for some extra credit points. But if you do need the whole period for the assignment from yesterday, that's also fine. And then when I see you on Thursday, we'll pick up where this video left off.